Good morning everyone. I am Deepika Rani, Assistant Professor in the Department of Computer Applications from SFR College, Sivagasi. Today I am going to discuss the topic critical section and mutual exclusion in operating system. In concurrent programming, multiple process uses shared resources. They work on same time. They use shared resources like printers, files, variables, memory, etc. In order to give safety for the shared resources, we must know the concept of critical section and mutual exclusion. So, the learning objectives: critical section problem, rules for critical section, process structure, requirement for solution to critical section problem, and mutual exclusion. Now let's move to the critical section. The critical section is a part of the program where a process tries to access shared resources such as printer, file, memory or variable. The main issue arises when two or more processes tries to access the same resources at same time. For example, if two students want to take printout of a document and they use the same printer, obviously one student has to wait till the other one takes the printout. The same way, the process has to wait till other process uses the shared resources. It leads to race-like condition where the output depends on which process executes first. This causes data inconsistency. To avoid this, each process must request a permission to enter critical section. Critical section problem. Let us consider a system consisting of n processes, namely P1, P2, P3 till Pn. So, each process has a part of code called critical section during when it uses shared resources. Rules for critical section. If one process is inside critical section, no other process is allowed to enter. Only one process can enter the critical section at a time. Once a process exists, another process waiting for the resource can enter. This type of coordination avoids conflicts and ensures correct result. This is the process structure. So, every process can be divided into 4 parts. The first is the entry section. Here, the code needs to get permission to enter into the critical section. Next is the critical section. Here, the process works with the shared resources. Exit section. Here, the process will try to release the shared resources that it has been using. Next is the remainder section. Here, the remaining part of the code will be executed. This portion will not need the shared resources. This is the process structure. The entry section. The process requests permission to enter the critical section. The critical section. The process uses shared resources. The exit section. The process releases control of the shared resources. Remainder section. The process executes the rest of the code which does not involve shared resources. This is the process structure. So, here the coding will be starting from the do. So, at the top, at the entry section, the code will start execute, then it gets permission, then it comes to the critical section. Here it will be accessing the shared resources. The next is the exit section. Here it will be releasing control of the shared resources. Next is the remainder section. The other part of the code will be executing. This part does not require the shared resources. This structure helps to manage resource sharing without any conflicts. Requirement for solution to critical section problem. To design a good solution for critical section problem, 3 main requirements are needed. First is mutual exclusion. At any time, only one process can be in critical section. Next one is progress. If no process is in critical section, another process in waiting must enter into the critical section without any delay. The third one is bounded waiting. A process should not wait forever. There must be a time limit, so all process can get a chance. The next is the mutual exclusion. Only one process can access a shared resource at a time. Example, if P1 is inside critical section, P2 and P3 must wait. It prevents race condition, data corruption and inconsistency. To achieve mutual exclusion, we use synchronization techniques like logs, semaphores and monitors. So here P1, P2, P3, P4 are the processes here. Here P1 has already entered into the critical section. P3 is waiting to enter into the critical section. P2 and P4 cannot enter into the critical section. They didn't get any permission to enter into the critical section. Conclusion. The critical section is essential for safely accessing shared resources in concurrent system. By applying mutual exclusion synchronization mechanism, we can avoid race conditions and data inconsistency. This makes the system efficient and error-free. Thank you for watching.